We've recently seen three completely different mathematical presentations: the idea of fractions, the idea of percentages, and this idea of ratios. Three completely different things, but they all seem to be doing very similar jobs. They're all about splitting up amounts or numbers. Fractions, about cutting stuff into equal pieces, keeping some of them to focus on and ignoring the rest. Percentages, finding a certain proportion out of an amount based on this idea of being out of 100, saying what if we were out of 100, how many of them would be what we want. So now how many of them out of what we've got are we looking at? And ratios, this idea of splitting stuff up into maybe 2 different groups, 3 different groups, as many as we like, but according to a certain proportion, some of one, some of another. So 3 completely different things, but they all seem to be doing very similar jobs, just in slightly different ways, with slightly different focuses. But there is a connection between the 3 of them. Now we're going to ignore the ratios, but it's worth pointing out that they are ideologically similar to fractions and percentages. We're just going to focus mainly on the connection between fractions and percentages. And this is really the point where some of these things, some of these connections that we've been making start to really come together. And we start to be drawing together all of the different content that we've seen so far in these number topics. Let's just think about fractions for a minute. Now, the very first thing we said about fractions was that actually, secretly, they are a divide. This line in the middle here is a line that means divide, and whereas this is 1/2, it is also 1 divided by 2. Now, we've not really treated fractions as a divide so much. We've used the idea of the divide to give us this cutting up into chunks idea, 2 pieces, because we're looking at a half type of fraction here. But we've not actually treated this as a divide. We've said that more often than not, it's worth bearing that in mind, but it just stays at the back of our mind. And when we first looked at fractions, I said there was somewhere we were going to come back to this, and we were actually going to look at this as a divide. It's always worth bearing in mind that fractions are a divide, and we will be coming back to this definition to do certain things with it eventually. So let's grab our calculators. So let's actually treat this fraction as the divide that it secretly is, and do on our calculators 1 divided by 2, press equals, and then press that S to D button to give us a nice numerical answer, rather than the calculator just returning the half again. And see what we've got. We've got 0.5. Because treating this fraction as a divide, 1 divided by 2 gives us 0.5. And suddenly, there is a connection. Not just between fractions and percentages and ratios, but actually fractions and the whole number system that we already have, between fractions and, in particular, decimals. And now, based on that, we can say that 1/2 and 0.5 are the same thing. But surely, if this is true, and we can do a half, treat it as a divide and turn it into a decimal, surely that's true for any fraction at all. Surely for any fraction at all, we can do the top number divided by the bottom number to turn the fraction into a decimal.
And so what we're going to do, this is going to be the first of our big ideas, that we are going to look at ways to switch between fractions, decimals and percentages. Fractions we've just seen are connected with decimals, and we've already talked a little bit about how fractions and percentages are connected in that they do similar things. Because it turns out that there is a way to switch between the 3 different presentations, that we can take any fraction and write it as a decimal or as a percentage, we can take any percentage and write it as a decimal or a fraction, and we can take any decimal and write it as a fraction or a percentage. And we just need to know how to be able to switch between the 3. Well, we've just seen how to switch from fractions to decimals, so that's the one we're going to fill in first. To switch a fraction to a decimal, all we need to do is do the divide. Treat the fraction as the divide that actually it is. Top number divided by bottom number.
Write the following fractions as decimals: 5/8, 3/10 and 1/3. So we've just seen how we convert from fractions to decimals. We do the divide, top number divided by bottom number. So we might grab our calculator. Some of these we might be able to do without, but we might grab our calculator. So 5/8 is going to be 5 divided by 8. We pop that into our calculator. We press equals. We maybe need to use the S to D button to get it as an actual decimal rather than just returning the 5/8, and we get 0.625. It's a longer decimal this time with 3 decimal places, but that's okay. okay, that's the answer that we get, and that is what 5/8 is as a decimal. 3/10, we're going to do 3 divided by 10. Top number divided by bottom number always. 3 divided by 10. We could maybe do that one with our hundreds, tens, units grid, because it's just taking the 3, dragging it down a column, and we're going to end up with 0.3. And 1/3 finally. We're going to do 1 divided by 3, and we're going to get, well, actually it's worth looking at this one a little bit more closely, because we're going to get one of 2 things on our calculators. On my calculator, I have done 1 divided by 3, I've pressed my Mr.T button, and I've got 0.333333333, and so on. Now, in fact, this goes on forever. This number does not stop. It just continues to repeat 3s forever and ever and ever and ever and ever. In terms of writing that down, I need to be very careful what I write. I cannot just write 0.3. Why can't I write 0.3? Well, because we've just seen that 0.3 is the decimal conversion for 3/10. The only way I could write that 1/3 is 0.3 is if 1/3 and 3/10 are the same. And if we consider those two, 1/3 and 3/10, there is no way to get easily from 1/3 to 3/10, so they are not equivalent fractions. They are not equal to each other, so we can't say that it is 0.3. What we can say, however, is that it is 0.33333 ... 3 is enough, 0.333 ... Whenever we've got this kind of repeating pattern, this number that goes on forever. 3 of them is enough, and then a ... This idea of decimals going on forever, it is said to be what's called a recurring decimal. Recurring as in repeats forever. And sometimes this would be said as 0.3 recurring, as in the 3 carries on forever. It is possible that on your calculator you did not get 0.333. And if you look very closely, you might have seen that you in fact got 0.3 with a little dot above the 3. Now that little dot simply means recurring. It simply means that whatever is underneath the dot goes on forever. You can use the recurring dot if you wish. If you are going to write down the decimal conversion for a fraction where this happens and we get this recurring pattern, this repeating number, you can either write this version here, 333 ... or whatever the number happens to be, or you can write this version here, but you have to put the dot on the top. If you miss the dot off and you just put 0.3, that is wrong, because 0.3 is the conversion for 3/10, not 1/3, or whatever the number happens to be. So you can use the recurring dot if you wish, or you can just do the 333 ... type presentation. Let's have a little bit of a look at percentages now for this next one. 68%. Well, if we go back to the definition of what that means, percent, remember, percent means out of 100. This is 68 out of 100. Now, how else could we write this idea of 68 out of 100? Where else have we seen a presentation that means out of? And look at that, it's fractions again. Surely 68%, 68 out of 100, is just 68 out of 100. So surely all we've done there is use the definition of what percent means. Percent literally means out of 100, and 68% is 68 out of 100. And we have written that percentage as a fraction. Can we cancel it down? We can actually cancel it down. We probably should, just because it's going to be slightly neater if we do. Well, both top and bottom are even numbers, so they will divide by 2. So we can do 34 on the top and 50 on the bottom if we divide top and bottom by 2. They will divide by 2 again, and we can go 17 out of 25. 17, however, is a prime number, and it turns out that that is as simple as it will go.
And if we've done that, then we can fill that in on our table. We know how to convert percentages to fractions. Now then, percentages to fractions, we simply need to write them over 100 using that definition and then cancel down. We should always cancel down because it's good practice too. If in the exam they're not looking for us to and we've done it anyway, that's fine, they'll just ignore it. But it's better to do it just in case.
Write the percentages as fractions in the simplest form: 19%, 40% and 3%. Well, to write the percentage as a fraction we've just seen, all we need to do is use that definition of the percentage, write our percentage over 100 and then cancel down. We have to cancel down this time because we've been asked to give our answers in the simplest form. So 19% literally means 19 out of 100, and we can then write that as 19 over 100. Will that cancel down? Well, actually 19 is a prime number, so it turns out that that one is already in the simplest form. 40% literally means 40 out of 100, so 40 over 100, there it is as a fraction using that definition. We just need to cancel down now. Well, clearly top and bottom will divide by 10, so we can go for 4 over 10, and then we could halve top and bottom to go 2 over 5, dividing top and bottom by 2. That's the simplest form though, so we can look at the final one. 3% literally means 3 over 100, and once again 3 is a prime number, so it turns out that that one is as far as we can go. Now there's something else we could do with these. So we've just seen that 19% is 19 over 100, 40% is 2/5, and 3% is 3 over 100. But there's something else we could do. We know now how to turn a percentage into a fraction. And we've also seen previously that we can rewrite fractions as something else. We have seen that we can rewrite fractions as decimals. So surely, if we now turn this fraction into a decimal, then we've turned the percentage into a decimal, ultimately. Let's do that though, because maybe in getting the answers we'll see a quicker way to go from percentage to decimal. Well, let's ignore the percentages for the minute. And let's just focus on these three fractions. And we know how to turn fractions into a decimal. We simply do top divided by bottom. So we're going to do 19 divided by 100. Maybe we pop that in our calculators, maybe not, but 0.19. 2 divided by 5. We probably are going to want to pop that in our calculators, but 0.4. And 3 divided by 100, 0.03. And then I'm going to reveal the percentages again. Let's just take away the fractions for a minute. And now, looking at those pairs of percentage and decimal, is there a connection between them? Well, I mean, I would say there was. 19%, 0.19, 3%, 0.03, and 40%, 0. Oh, hang on. But couldn't we rewrite this? Couldn't we add something in afterwards? If I put that on the end, the number has not changed. And suddenly, 40% and 0.40. So what have we actually done to get from percentage to decimal? What we've actually done is we have shifted our numbers 2 spaces down the columns in the hundreds, tens, units grid, and we have divided by 100. What we've actually done. But practically speaking, we could surely use a bit of a trick and just take the percentage number, stick a 0 point in front of it, with the exception of this, of course, remembering that it's a 0.03, and just write it by looking at it. Surely. Can't we?
So we can fill in the next one in our table. We've just seen how we go from percentage to decimal. Percentage to decimal. Properly speaking, we divide by 100. Because a percentage is an out of 100, we are always going to be properly dividing by 100. But practically speaking, if we're doing questions, we can probably get into the habit where we can just do it by eye and write down the answer.
Write the percentages as decimals: 72%, 80%, 5% and 17.5%. So we've just seen how we write percentages as decimals. Properly, mathematically speaking, we are going to divide our percentage number by 100. Practically speaking, we can just do it a bit by eye. So 72% dividing by 100 properly, or just doing it by eye, will be 0.72, where the digits are the same and they've just shifted down the hundreds, tens, units column. 80% will be 0.80, but actually we don't necessarily need that 0 on the end, so we could lose it because it's still the same number without. So we could just write that as 0.8, but you can put the 0 on the end if you'd like. 5%, well, it'll shift 2 spaces down the column, so that will be 0.05. And 17.5%, a bit weird because there's a decimal in there, but there's nothing wrong with having a decimal percentage, it's fine. 17.5%, somewhere between 17 and 18%, would in fact be 17% will be 17. The 5 is going to have to go somewhere, so it would be 175, 0.175.
Now actually we've just seen how to do percentage to decimal. Surely decimal to percentage going the other way would actually be just the same but in reverse. So properly speaking, well, if we're dividing to go from percentage to decimal, surely going decimal to percentage, we just times by 100. And practically speaking, actually, we could just do it by roughing it from looking at the numbers that we're dealing with.
So write the decimals as percentages: 0.58, 0.09 and 0.7. Properly speaking, what we're going to do is we're going to take each of these and we're going to times them by 100. Practically speaking, what we can actually do is we can just do a bit of look at the numbers and work out what it will have to be. So 0.58, if we do 0.58 times 100, we're going to get 58%, but notice again that the numbers line up. 0.09 times it by 100, it's going to shift 2 spaces up the columns, and we're going to get 9%. And 0.7, well, really it's 0.70, and we can put that 0 on there if we like to help us, and it will be 70%.
And actually, the 4 conversions we've looked at so far are the most useful 4. And in fact, there's nothing too technical going on here. There's nothing too fancy or surprising. The first one, fractions to decimals, we just used the definition of what the fraction was, that line in the middle is a divide. We just treated it as the divide that it's always secretly been. Percentage to fraction, we used the definition of a percentage. And then the other two, timesing by 100 and dividing by 100, actually there's a handy shortcut that we can do, and we can get into the habit of just being able to do that by looking at the numbers. So there's nothing too fancy going on here really, and it's all skills we've used before. And they are the most useful 4. They are the ones you're likely to have to do. And in fact, the other 2 on here, fractions to percentages and decimals to fractions, really are just combinations of those 4. It's convert it to the other one and then into the one that you want. So fraction to percentage, we're going to go fraction to decimal and then decimal to percentage. Properly what we're doing is we're going to do the divide, that's the fraction to decimal bit, and then we're going to times by 100 to go from the decimal to the percentage. For example,
write the fraction as a percentage, 9 over 15. So to write something as a percentage, we need to get it out of 100. There is no easy way to rewrite this fraction so it's out of 100 instead of being out of 15. If it was out of something we could easily scale into 100, then fine, great. This one isn't. We're not easily going to be able to get from 15 to 100. And to take a fraction and write it as a percentage is quite a tricky thing to do in one go. It's not the easiest thing, but we can always rewrite it as a decimal. It's easy enough to rewrite this fraction as a decimal, so we're going to do that first. We're going to do 9 divided by 15 to get the decimal. I'm definitely going to grab my calculator for that. I'm going to do 9, I'm going to divide it by 15, and I'm going to press my Mr.T button if I need to. And I'm going to get 0.6 out of that. That's 9 divided by 15. So there's our first step. We're going to do the divide, i.e. turn it into a decimal first. Now I've got it as 0.6. Well, I might want to tweak that slightly. I could make that 0.60. Why? Because now I can easily rewrite it as a percentage and say it is 60%. And 9 over 15 must be 60%. So you see, no easy way to go from fraction straight to percentage, but we can turn it into a decimal first, and then we can turn it from a decimal into a percentage. So it's just a combination of 2 different conversions.
And the final one, decimals to fractions, once again, is a combination. There's no easy way to go from a random decimal into a nice neat fraction, but we can easily go from decimal to percentage and then percentage to fraction. So the first thing we're going to do, we're going to go decimal to percentage, i.e. we're going to, properly speaking, times it by 100. Practically speaking, all we're doing is we're just using the pattern spotting to write that as a percentage. And once it's a percentage, we can simply go percentage to fraction. Well, let's treat the percent sign as what it actually means, percent out of 100. So we write it over 100 and then we cancel down to the simplest form of the fraction. Seems a bit more complicated, this one, but again, it isn't. It's just convert it to the percentage first and then to the fraction. Use what we already know to find a slightly more complicated thing to do.
Write the decimal as a fraction in the simplest form, 0.36. So 0.36, a perfectly reasonable but completely random decimal, and there's no easy way to pick a fraction, even a type of fraction, out of thin air to know what to rewrite that as. But there is something that we can easily rewrite 0.36 as, and that is as a percentage. 0.36 as a percentage is going to be, either from the pattern spotting or from the more proper mathematical timesing by 100, is 36%. And now that we've done that, there's our first step, so we've times by 100 to turn it into a percentage, and then our second step can be, well, 36% literally means 36 out of 100, so we can rewrite that, 36 out of 100, and there we go, we are looking at a fraction. But that's not the whole story, because we wanted our fraction in the simplest form. The question specifically tells us to do that, so we need to cancel that down if we can to get it into the simplest form. 36 and 100 are both even numbers, so they will both divide by 2. So we could divide by 2 on the top and get 18, and we could divide by 2 on the bottom and get 50. 18 and 50 are also both even numbers, so we could divide by 2 on the top and bottom again. We could do 9 on the top and 25 on the bottom. And it turns out that that is it. 9, the smaller of the two numbers, well, if we discount the 1, because 1 isn't going to be useful, 9 will divide by 3 or 9, and 25 will divide by neither of those, so it turns out that that is the simplest form. And 0.36 and 9 over 25 are the same. So the most basic type of exam question that you could be asked along these fraction, decimal, or percentage lines is exactly what we've already been looking at. Here is a fraction, a decimal, or a percentage converted into one of the others. There are other types of questions we can look at as well, though. A hotel has 56 guests. 35 of the guests are male. Work out 35 out of 56 as a percentage. This is a 2-mark question, so there will be one for some attempt towards working it out, and then one for the actual answer. Keywords in that bit, well, actually the key phrase is the 35 out of 56 as a percentage. 35 out of 56 is neither fraction nor decimal. But this is one of these converting questions because we're trying to write something as a percentage. But 35 out of 56 should tip us off to how we're going to start this question. 35 out of 56 surely we could write as 35 out of 56 and write it as a fraction, and that says 35 out of 56. Now this is a fraction and the question wants us to have a percentage. So what we need to do is we need to take this fraction, 35 out of 56, convert it into a percentage. How do we do that? Well, we think back, we look at our table maybe, we remind ourselves, and fraction to percentage is one of these more complicated ones. Well, we've got to go via decimal first. So we're going to convert this fraction to a decimal first of all, and then use that decimal answer to turn into a percentage. We're going to grab our calculators. We're going to do 35 divided by 56 on our calculators, press equals, press the S to D button if we need to, and we're going to find that we have got 0.625. But that's still not the whole story, because we need to actually rewrite that as a percentage like the question wants us to. So to go from decimal to percentage, we need to either properly times by 100, or we can rough it from what we've got there. We can look for the patterns. Well, if it was 0.62, it will be 62%. The 5 is going to have to go somewhere, so clearly it's going to be 62.5%. 6%. And if we do 0.625 times 100, we get 62.5. And our answer to this question then for the 2 marks, 62.5%. The other important type of question that uses these conversions specifically, write these numbers in order of size, smallest to largest, and then a collection of fractions, decimals, and percentages. The key thing with these questions is that these numbers will all be very similar in size. The problem here is that it's very difficult to compare fractions, decimals, and percentages. Imagine we had different currencies of money. The only way we could compare the values of, say, pounds, dollars, and euros is to have all three in the same currency. All three as pounds, all three as dollars, or all three as euros. Or, I suppose, all three as something else. The same is true of these questions. We need all of the different numbers in these questions to be the same type. We need to have them all as percentages, or all as decimals, or all as fractions. Which one? Well, actually, it doesn't matter. You just need them all in the same type so that you can compare. You get to pick whichever one you're more comfortable with. But I would give you a word of advice. Turning everything into fractions is probably going to be a lot more work. Partly because it's a bit harder to turn some of these into fractions, and then you're going to need to get the fractions to be equivalent. So that's a lot more work, and these questions are probably only worth 2 marks, maybe 3 at most. That's a lot of work for 2 or 3 marks. It is easier to turn them all into percentages or into decimals. And I will give you another tip. Which of those you choose might depend which paper you are on. If you are on the calculator paper and you have your calculator, I would strongly suggest you turn all the numbers into decimals. Why? Because it is very easy to turn a fraction into a decimal when you have a calculator. But again, any of the 3 will work, and as long as you have them all in a comparable form, you can do these questions. So the 65%, let's rewrite that as a decimal. Well, that's going to be 0.65. 7/10, we're going to do 7 divided by 10. We might grab our calculators if we like, but 0.7. We could even put the 0 on the end there if we want, just to make it a bit easier to use. 0.68 is already a decimal, so that's fine. We don't need to do anything with that. 2/3, we're going to do 2 divided by 3 is 0.666 ... Or 0.6 with the recurring dot over the top if you like. Either is fine. I'm going to prefer to use this first one, but either is okay. And the 3/5, 3 divided by 5 is 0.6, just 0.6, not recurring. So we've got 5 numbers now that we can compare: 0.65, 0.7 or 0.70, 0.68, 0.666 ... and 0.6. We now need to put them in order of size. The 0.6 is the smallest. Then the 0.65. Then the 0.666. 0.68, and then the 0.70 at the end. And if I do that, and I give that as my final answer, then I only get one of the marks available. I do not get the mark for the answer. Why not? Because I need to look back at the question. Write these numbers in order of size. And these that I've written in blue are not the numbers that were in the question. I need to make sure I convert them back at the end. And the original numbers need to turn up in my final list. So the 0.6 was 3/5. So that needs to be that first one there. 0.65 was 65%, so that's my second one. The third one, 0.666 ... was the 2/3, so the 2/3 comes next. Then the 0.68, well, that was a 0.68. And then finally, the 7/10 is the largest. And if I do that, then I get the 2 marks for the question. One for converting something to try and get them in a comparable form, and then one for the actual list at the end in the right order. Final thing it's worth doing with this fractions, decimals, percentages is working out the conversions for some standard common fractions that it's worth bearing in mind. So you need to know these by heart? No, but it is helpful if you can recognise at least these first 4. the conversions for a half, a quarter, a tenth, and a third. Well, a half, 1 divided by 2 as a decimal would be 0.5, and we saw that first of all, which we could rewrite as 50%. So a half, 0.5 and 50% are standard conversions. And that actually makes sense. If you think about 50%, it's half price. We all know that. 1 quarter, 0.25 and 25%. 1 tenth, 0.1 if we do 1 divided by 10. And 10%. And 1 third, 0.333 ... and 33.333 ... percent. 4 standard conversions, and actually we can use those 4 to get 2 extra ones. Well, if 1 quarter is 0.25, then 3 quarters will be 3 lots of that at 0.75, and that must be then 75%, which notice is also 3 times the 25%. And if 1 third is 0.3 recurring, then 2 thirds will be 0.6 recurring, 0.666 ... and 66.666 ... percent. Again, do you need to know these conversions by heart? No, but it is helpful if you can recognise at least those first 4, because these extra 2 can come out of that. If you can recognise a half, 0.5, 50%, quarter, 0.25, 25%, and the other 2 for a tenth and a third, that is particularly useful because you'll be able to write those down quickly straight away without having to use your calculator. One more useful thing that comes out of this, if 1 tenth, 0.1 and 10% are all the same, different ways of writing the same information, we should be able to easily work out 2 tenths from this. Well, 2 tenths is just going to be twice as big. So if 1 tenth is 0.1, then 2 tenths will be 0.2. And if 1 tenth is 10%, then 2 tenths will be twice as much at 20%. And hopefully we're starting to see a pattern here. 1 tenth is 0.1 is 10%. 2 tenths is 0.2 is 20%. We should be able to write down then any tenths information without needing to think too much. 7 tenths, 0.7, 70%. 4 tenths, 0.4, 40%. 5 tenths, 0.5, 50%. 9 tenths, 0.9, 90%. And there's a nice bit of pattern spotting there as well. And the final interesting thing we can get from this, if we think about these 2, for example, 1 tenth, well, we've just seen that 1 tenth can be rewritten as a decimal as 0.1. We haven't seen yet anything about 1 over 100, but 1 over 100, we could write that as a decimal. 1 divided by 100 is 0.01. There's something interesting there, and it answers an old question that I said we would come back to and we would explain at some point. You may be wondering why they are called tenths, hundredths, and thousandths, and you may also be wondering why there isn't a uniths. These are all questions that we will answer in future weeks. For now, just take it as given that they are called tenths, hundredths, thousandths. There are also easier ways to write these. You might see this written as 1 over 10, you might see this written as 1 over 100, and you might see this written as 1 over 1,000 with lines in the middle. They are again all perfectly valid, they do mean the same thing, and in future weeks I will explain why. But we're not going to go anywhere near that just yet. We're going to focus just on the names for now. Tenths, hundredths, thousandths. And actually it doesn't really matter what the names are, because they just function in the same way as these other columns. 0.1. If you think about your hundreds, tens, and units, you've got your units, and then you've got your tenths. Where would 0.1 go in that? It would go 0 in the units and the 1 in the tenths. And any presentation like that, 1 tenth is 0.1, 2 tenths 0.2, 3 tenths 0.3, and so on. The digit part, this here, the how many tenths, is going to end up in the tenths column. And in fact, that is why this column is called the tenths. Because it's where the decimal conversions of the tenths, 1 tenth, 2 tenths, 3 tenths, and so on, would end up. Same with the 0.01. If you think about your hundreds, tens, and units, we'd have the units, the tenths, and then the hundredths. And 0.01 would end up with the 1 digit being in the hundredths. 1 hundredth, 0.01, and 0.01 in the hundredths. And in fact, any number of hundredths would end up in that column. 2 hundredths would end up 0.02 and a 2 in the hundredths. 3 hundredths, 0.03, and a 3 in the hundredths, and so on. So in fact, that is why this column is called the hundredths. Because the decimal conversions shift you into that column. As soon as you are looking at a tenths fraction, your decimal conversion is giving you a number in that presentation and leads to the rise of the name tenths. And as soon as you're looking at a hundredths type fraction, the decimal version of that shifts an extra column onto the grid, the hundredths column, because we're looking at hundredths, and it's hundredths type fractions that do it.